Hi, boys and girls. This video is on 7-2 angle relationships and triangles. Right. And I have no camera on because I'm on spring break and I have no makeup and my hair's not straightened. So you're just going to have to live with it. Also, if you hear a dog barking, it's because I'm at home. All right, angle relationships and triangles. You're going to be able to find the measure of interior and exterior angles and triangles by using the relationships between the angles. So words that you're going to be learning: exterior angle, interior angles, line segment, remote interior angles, triangle, and vertex. Some of those you already know. Okay, line segment is part of a line containing two endpoints and all of the points in between them. I think that's pretty straightforward. A triangle is formed by three line segments that intersect at their endpoints. I can give you a visual here. You've got your typical line segment, which is a line with two points at each end and contains all the points in between. A triangle is made up of three of those put together that all meet at their endpoints, three line segments. And the points where they intersect is called a vertex. But anytime two lines intersect at a point, it's called a vertex. All right, the three angles that are on the inside of the triangle are called interior angles. All right, let's see, and we can write triangle like triangle. You draw a little triangle and then you do like triangle ABC. So if this was ABC, that's how you name your triangle. Okay, line segment is just a little bit of a line like that. This would be referring to line segment CA, would be this line here. Okay. And that's pretty much all it says. All right, so here we want to use some of this. They want you to label the sides. So they've labeled the first one for you XY. Now we could label YZ. I guess they're highlighting it in green, the one they want us to do. And this would be segment XZ. And remember, with segments, you have a little line over the top. Okay. Down here, they want you to label the vertex that they've highlighted. This is vertex Y. This is vertex Z. And here they're talking about specific angles. This is angle X. This is angle Y. You see Y is highlighted. You put the little angle symbol in front of it. And then this would be angle Z. Now, another way to name angles is to use three letters. You would put like, say, for example, if I'm naming this one right here, okay? You use all three letters, but the middle one has to be the vertex of the angle. So I could name this triangle YZX. I could also name this angle XZY. Both are legit because Y or Z is the middle letter and Z is the vertex. It has to be the middle one. Okay, this is a little activity where they want you to have a cutout of a triangle in which you cut off, you tear it apart like this so that you have the three angles of the triangle. And then if you line them all up together, they make a straight line. Okay, they're trying to show you that if you add them all together, they would equal 180 degrees. And that's one of the rules that we use a lot with triangles. We know that if we add all three of their angles together, it equals 180. So down here, they've given you another example of a triangle. They've given you 110 plus 25 plus 45 equals 180. I just want you to show that you know the three angles of a triangle equal 180 degrees. And this basically just says what I just told you. If you add the three angles of a triangle together, you get 180 degrees. Okay, so now we're going to go to an example of a triangle where we have a missing angle. You might be thinking we have two missing angles, but this little square tells us that this is in fact a 90-degree angle. All right, so we know two of the angles and we're trying to find the third one. So what we would have here is we know that X plus 56 plus 90 is equal to 180. So this would be, if I had this together, it'd be 146, okay? And then if you subtract 146 from both sides, we figure out that the measure of X is 34. So that tells us that the missing angle was 34 degrees. If you know two of the angles of a triangle, you can always find the third. All right, so what is X in what is the value of X in the doghouse? They want us to find this angle right here. Okay, we know these two. So what we would do is we would say, okay, 86 plus 47 plus x equals 180. Well, if you add 86 and 47 together, give me a second, I do have a calculator on me. 86 plus 47 equals 133. That's supposed to be 180. Now we want to get x by itself, so we'd subtract 133 from both sides. And we get that x is 47 degrees. Interesting. Those are both 47. That means this is an isosceles triangle. That means this side and this side are the same length. Different lesson, not this one. Okay, now I do have a handout for you. If I have forgotten to give it to you at this point, you should remind me that I have a handout to give you. I want you to get a little practice with finding the missing angle of a triangle before we complicate this and throw word problems in there. What you will do in each case is you will set it up like this: 61 plus 75 plus b, the one we don't know, have to add up to equal 180. And then you will add those two together. That will give you 136 plus b equals 180. And then you subtract 136 from both sides, and you arrive at b is 44 degrees. Okay. Same thing you would do here. You would do 34 plus 32 plus b equals 180. Add those two together and you would get 66 plus b equals 180. And then when you subtract 66 from both sides, you will get b is equal to 114. So I'd like you to go ahead and pause the video, and then when I want you to try to solve 3, 4, 5, and 6 on your own, and then you can come back and check your answers against mine. Okay, so go ahead and pause it now. All right, welcome back. All right, for number 3, you should have realized that, of course, this is a 90-degree angle. So our equation is 52 plus 90 equals, plus b equals 180. Got ahead of myself there. 52 plus 190 is 142 plus b equals 180. And then when we subtract 142 from both sides, we get that b is equal to 38. Likewise over here, 40 plus 57 plus b equals 180. 40 plus 57 is 97. Subtracting 97 from both sides gives us b is equal to 83. The last two examples that you have on your handout are these. This is what's called an equilateral triangle, all right? If these two angles are 60, this one has to be 60 also, because 60 times 3 is 180. So this is an equilateral triangle, and because all three of these angles are 60, that tells us that each one of these sides is the exact same length. If you had not known that, and you had gone through and did the steps that we've been doing, you would do 60 plus b equals 180. That would be 120 plus b equals 180. And then you subtract 120 from both sides. And of course, you arrive at the solution we already knew we had, is that b is 60, same as the other two. And lastly, on number 6, again, this is a 90-degree angle. So we have 90 plus 66 plus b equals 180. 90 plus 66 is 156 plus b equals 180. And then we would subtract 156 from both sides. And we arrive at b is equal to 24. Okay? So that's how you solve for the missing angle in a triangle. And there will be several of those on the practice, because I want to make sure that you can do that reliably. Back to your workbook on page 396. use ratios to find angle measures. This is a little tricky here. What they're doing is they're giving you a ratio of the three angles. And what they're saying is you take those three numbers and you write them as an equation. So this would be 1x, that's the first angle, plus 4x, that's the second angle, plus 5x, that's the third angle, equals 180. And they got these numbers from here, here, and here. So you just take those three numbers and put them in front of the x's. And then you add them all together to give you 180, which is what they have here. Okay? Adding those x's together, you get 10x. And then you would divide both sides by 10, and you arrive at the solution that x is equal to 18. But they want the measures of the angles. They don't care what x is equal to. All right? Well, one of the angles is going to be 18. All right? But what about this guy? He's 4 times 18. Okay, so you would have to multiply 4 times 18 for him, and this guy is going to be 5 times 18. All right, so make sure that you go back and substitute x in each of these to be able to solve for the measure of the angles. Okay. All right, so here's another example where they've given us a ratio. Okay, so we're going to do the exact same thing. We're going to do 1x plus 2x plus 5x equals 180. 1 plus 2 plus 5 is 8. X equals 180. And then we divide both sides by 8. And we get that x is equal to... All right, hang on. 180 divided by 8. X is equal to 22.5. Okay, so one angle, the first angle, the 1x, is equal to 22.5. But what about 2x? Well, 2x is equal to 45. And then 5x, you would do 5 times 22.5 is 112.5. That's not a decimal. This is 112.5. And if you add all those three together, you can check your work and see that it does, in fact, add up to 180. Now, here's where it gets interesting. When we start talking about the exterior angles of triangles, now these are no longer line segments. These are actually rays because they have an endpoint and then they continue on forever in the other direction. So these are three rays that are forming a triangle. And now we got to talk about exterior angles. Try to bear with me. This is fascinating, but it's not exactly straightforward. The exterior angle, like say for example this guy here, is always going to be equal to the sum of the two remote interior angles, not the one that he's back to back with, okay? His measure will equal this one plus this one. Why you say that, Miss Williamson? Why is that true? I'll tell you. Here's why. Doesn't 5 and 3, don't those add up to 180 degrees? All right, so if you add 3 to both of these two, doesn't that equal 180 degrees? So if 3 plus 1 plus 2 is 180 degrees, and 3 plus 5 is 180 degrees, doesn't 5 equal 1 plus 2? It does, okay? And so we can use the concept of the exterior angle to solve for missing angles in a triangle, right? So the thing you need to remember is that any exterior angle is equal to the sum of the two remote angles, interior angles. So if we were looking at, let's see, angle 6 here, angle 6 would be equal to the measure of angle 1 added to angle 3. Now, the only angle you don't use is the one it's back to back with. It equals the sum of the two it's not touching, okay? So that's what they're trying to tell you here. Saying the measure of angle 4 and the measure of angle 1 equals 180. So you've got right here, 4 and 1 would equal 180. But 1 and 2 and 3 equal 180. So 4 has to be equal to 3 plus 2. Okay? And I don't mean 3 plus 2, I mean the measure of angle 3 plus the measure of angle 2. So the measure of angle 6 is equal to the measure of angle 6 plus the measure of angle 2 is 180, because see here, 6 and 2 equal 180. The measure of angle 5 and the measure of angle 3 equal 180. See right there, those equal 180, right? So we're still on page 397. Okay. Each exterior angle of the triangle has two remote interior angles, and this is what I was telling you on the last slide. This guy is going to be equal to this one plus this one. This guy is going to be equal to this one plus this one, and this one is going to be equal to this one plus this one. The exterior angle is equal to the sum of the two angles it's not touching. Okay. Which angles are remote interior angles in relation to angle 5? Well, here's angle 5. So 3 is not one of them. Because it's touching number 3. So 1 and 2 would be the remote interior angles. Which angles are remote interior angles in relation to angle 6? Here for number 6, 2 is not, 1 and 3 are. It's the ones it's not touching. All right, watch the video to learn about the relationship between an exterior angle of a triangle and its two remote interior angles. Well, you don't have access to that. You're stuck with my video. But what they're saying is here's your exterior angle, and it is equal to this angle plus this angle, right? So if we add 60, 65, and 66 together, those are the three angles of our triangle. Those add up to 180 degrees. 65 plus the 115 angle equals 180 degrees. See, they're trying to make the point that these two add to 180 and these three add to 180. So what they've done here is they've set these two equal to each other. They're saying if this one, the three measures of the triangle, are equal to these two, that's right here, all right? And then they do this little proof thingy to show you that you get 60 here plus 55 equals 115, which we know is true, okay, because 65 plus 55 equals 115. Okay. So let's see how we can use this little rule to our advantage. All right, well, this basically says the measure of angle 1 is equal to the measures of angle A plus B. And right away, they throw a chair at you. I mean, they couldn't just give you a triangle. No, they have to throw the chair in there to complicate things. Find the measure of angle 1. Measure of angle 1. Angle 1 is an exterior angle. It is going to be the measure of angle 2 added to the measure of angle 3. And what luck, they've given us both of those measurements, okay? The measure of angle 2 is 55. The measure of angle 3 is 60, which gives us 115. So the measure of angle 1 is 115. They didn't literally throw a chair at you, but you get what I'm saying. Here's your check. In the roof frame shown, the measure of angle 2 is 25, so this one's 25 degrees. The measure of angle 3 is 45 degrees. Find the measure of angle 1. Well, the measure of angle 1, now we're looking at this as a triangle, okay? We're not paying any attention to this little piece here. That means nothing to us. This is the triangle we're considering. This is an exterior angle. It will be equal to 2 added to 3. So 25 added to 45 is 70. So the measure of angle 3 is 70 degrees. Okay. Example 4, we're getting there. Sorry, I'm trying not to make this too incredibly long. Use exterior angles to find missing angle measures. In the figure, the measure of angle 4 is 135. So this is 135 here. All right, angle 4 is an exterior angle. Its two remote interior angles are angle 2, that's this one, and angle LKM. LKM means this one right here. Okay, so here's what they've given us. We know this is 135. We know angle 2 added to LKM has to equal 135. And we know K is 90 degrees, don't we? So that's what we put here because the measure of LKM is 90. And the measure of angle 4, we're told, is 135. Okay? So now if we subtract 90 from both sides, we get that the measure of angle 2 is 45. Since angles 1 and 4 are supplementary, the sum of their measures is supplementary, makes a straight line. Remember, supplementary starts with an S. Straight line. So the measure of angle 1 is 180 degrees minus 135, or 45 degrees. Okay? because we know that this measure of angle 1 has to equal these two added together. Okay. So here we have a check. All right, I hope we're getting to the end of this. I feel like I've been talking a long time. The measure of angle 5 is 147. So this guy right here is 147, which means he's going to be equal to this one plus this one. All right. Well, they want the measures of angles 1 and 2. Well, we can definitely find 1 because we know that 147 is equal to a 90 plus the measure of angle 1. All right. So if we subtract 90 from both sides, we get that the measure of angle 1 is 57. All right. So 1 is 57. This is 90. We can now find 2. These are like the problems we did at the beginning, where the measure of angle 2 plus 57 plus 90 equals 180. 57 plus 90, measure of angle 2. 57 plus 90 is 147. Okay. Subtract 147 from both sides. And we get the measure of angle 2 is 33. So this one's 33. And if you add 33 and 90 and 57, that equals 180. Oh boy, here's where it gets interesting. Okay, applying these with geometry. I think I'm going to make this a separate video because this is going to be quite challenging, and I think I've put enough on your plate right now as it is. So we will do these in the next video, and we're going to need a secret word. And I tell you what, I hadn't really put a lot of thought into it, but you know what it did yesterday? It snowed. It snowed on our spring break. So our secret word is going to be snow. Yes, that's right, boys and girls. We went on spring break and it snowed. I was pretty disappointed, actually. Okay, so that's it for this video. We're going to do these application and geometry problems in the next exciting adventure of 7-2 angle relationships and triangles. All right, until then, have a great time, and I will see you guys in class.